Good morning, students. So today we will talk about the types of the microcontrollers. So in this lecture we will talk about the type of the microcontrollers and how they can be used in the embedded system. So on the base of the types, the microcontrollers can be divided into 4 types, and that is on the base of bus width, memory, instruction set and memory architecture. We can divide the microcontroller on the base of 4 points. Okay, so first of the thing is the bus width. So whenever we say that how good any of the microcontroller, so we can say that this must have the either it has the 8-bit microcontroller, 16-bit microcontroller or 32-bit microcontroller. So basically in that case we have 3 types of the microcontrollers when we talk about a bus width. So larger the bus width, more the data can be handled by a microcontroller. Okay, so let's see that if it is a 8-bit microcontroller, so means the ALU of the microcontroller can handle 8-bit of data in a single unit of time. Okay, so my data can be of 8-bit, right? If it is 16-bit, if it is a 16-bit microcontroller, so my ALU can perform at 16-bit of the controller. 16-bit the data of 16-bit can be handled by my ALU. Okay, similarly is for the 32-bit. So larger the size of the data bus, size of a data bus, and so larger the amount of the data we can handle in the ALU, and so the processing of the so you can say that yes, so 8-bit micro means larger the amount of the data handled is by the ALU, and by the ALU, so larger means better the microcontroller. So that depends on the application, that how we can use it in our application. So that may possible that your application is very small, and we for that application we should use a smaller number of bits microcontroller. If my application is larger, for example graphical applications or something like that, so that for that case we should use my application for the larger space, and so in that case 32-bit of microcontroller can be used. For middle applications, for example the IoT applications and all, 16-bit microcontroller is perfect for that case. So that is a classification of the microcontroller on the base of bus width. So when the exam will come, then you have to write on the base of bus width, on the base of classification on the base of bus width, classification on the base of memory, classification on the base of instruction set, classification on the base of memory architecture. So you should write that. Okay, so in the case of the memory, if the embedded system has may have the internal memory or the external memory. So you can say that here the embedded memory means my on-chip memory is there. So for that case my on-chip memory is there, so means my CPU is there, and there is an internal memory. Which holds the data and code. So there is an internal memory in that case, and it holds the data and the memory both, right? So for the another case it is for the internal. If it is an external memory, so my system is there, some embedded system is there, so in which my microcontroller is available, and in that case we have to insert a memory as a separate part, right? So we need to interface my memory from that microcontroller, and that is my external. So my memory system, on the base of the memory system we can divide the microcontroller in 2 types. One is embedded memory and another is external memory. Next is instruction set. On the base of the instruction set, it is a complex instruction set computing, and RISC is a reduced instruction set for computing, right? So these are two types of the instruction set. Means when we decide each and everything for use for our computing system, right, then it is a complex instruction set computing. If we define some very necessary instructions for my computing system, then it is a reduced instruction set computing. Okay, so we will I will elaborate these two things in my next lecture. Next is memory architecture. On the base of the memory architecture, these are two types: Harvard architecture and von Neumann architecture. The Harvard architecture, I will discuss these two things also in my next lecture. And basically it is that how the memory is associated with the CPU, how the CPU takes the data from the memory. That depends on these two things. In Harvard case, we have separate data memory, separate code memory, and CPU basically fetches both the data and the code simultaneously. While in von Neumann architecture, we have one memory, and in this memory both code and data is available. So that is a von Neumann architecture. In my next lecture, I will tell you about and I will elaborate about these two things basically. So thank you for this lecture. In my next lecture, I will tell you about processor architecture and Harvard versus von Neumann architecture. So thank you.